All right, let's pull back the curtain on a bit of invisible magic that honestly powers our entire digital world. It's called data compression, and it's the unsung hero that makes everything from streaming movies to just sending an email not just easy, but even possible.
I mean, think about it for a second. You snap this gorgeous high-res photo, you hit send, and boom, it's on your friend's phone in a flash. How in the world does that giant file shrink down enough to travel so fast? Well, that's exactly the question we're diving into today.
Okay, so first things first, we've got to grasp the scale of the problem here. Without any kind of squeezing or shrinking, the files our devices create are, well, they're enormous. You could say they have a serious digital weight problem.
So, how do you actually figure out a file's digital weight? Well, here's the basic math. You take the width and height in pixels, multiply them together. Then you multiply that by something called color depth. That's just how much info is in each little pixel. After a bit of division, you get the final size in mebibytes, or MIB. It's kind of like megabytes or MB, just a more precise way computers measure things. And trust me, this number adds up incredibly fast.
Let's put this into perspective with a real-world example. Imagine a pretty standard camera sensor, about 2048 by 2048 pixels. Now, if we run that through the formula, how big do you think that one single photo would be, completely raw and uncompressed? Take a guess.
8 megabytes. Yeah, for one single photo. Now just try to imagine sending 100 of those to your family. Or streaming a movie, which is basically thousands of these images every single minute. Our internet would just grind to a halt. It would be completely unusable. And this is where our hero finally enters the story: data compression. This is the amazing tech that was literally designed to solve this exact digital weight problem. And in doing so, it makes our modern lives possible.
So why do we bother squeezing these files? Well, for some super practical reasons. For one, it saves a ton of storage space on our phones and computers. It also makes downloads and streaming way faster. Plus, it uses less internet bandwidth, which reduces the strain on the whole system and, yeah, ultimately saves everybody money.
Okay, but here's the thing. Not all compression is created equal. There are actually two totally different ways to make files smaller, and they're based on completely different philosophies. So, let's dive into the first one.
This first method is the one you probably interact with the most every single day, even if you don't realize it. It's called lossy compression, and its whole philosophy is basically good enough is perfect.
So with lossy compression, the algorithm is smart. It looks at the file and literally throws away bits of data that it decides are unnecessary or that you're probably not going to notice anyway. And here's the crucial part. That data is gone forever. You can't get it back.
And believe me, you use this all the time. The music you stream, that's an MP3. The videos you watch on your phone, those are MP4s. And the photos you share online, JPEGs. All of them use lossy compression to stay small enough to send around.
So how does it know what to throw away? This is the really cool part. It actually exploits a little quirk in our own biology. See, your eyes are amazing at noticing changes in brightness, the difference between light and dark. But we're not so great at seeing tiny, subtle shifts in color. The JPEG algorithm knows this, so it throws away tons of color information while keeping all the important brightness stuff, and our brains just fill in the gaps. We barely even notice. And that one simple trick, right there, is pretty much what made sharing photos online possible for everyone. But what if good enough is actually a complete disaster? What if you need every single bit of data to be absolutely perfect? Well, for that, you need the other method, lossless compression. And just like the name says, lossless compression shrinks a file without losing a single bit of the original information. Think of it like packing a suitcase really well. Everything you need is still in there, it's just packed tightly to take up less space. You can always unpack it later and get everything back exactly as it was.
So when would you need this? Well, think about something like a computer program or a spreadsheet with your finances on it. If you started throwing away a few unnecessary bits of data there, your program would crash or your budget would be totally wrong. For that kind of stuff, perfect one-to-one reconstruction is absolutely non-negotiable.
So how on earth does it get smaller without losing anything? Let's look at one of the simplest and oldest tricks in the book, called run-length encoding. Its job is super simple, but really clever. It just looks for things that repeat. This is a perfect, simple example. Instead of writing A, the computer just makes a little note that says, hey, give me 5 A's. Instead of B, it says 3 B's. See? It's the exact same information, just described in a much shorter way.
nothing is lost.
And that exact same logic works for images too. Take a look at this letter F. You see all those long stretches of white pixels and then the stretches of black pixels? Instead of storing every single one, the computer just says, okay, 9 white pixels here, then 6 black pixels here, and so on. It shrinks the file down, but you can still rebuild the original image perfectly with zero loss of detail.
So, at the end of the day, we've got two really powerful tools in our toolbox. One that's all about getting the smallest possible file size, and another that's all about perfect, pristine quality. And choosing between them is this constant trade-off we make in the digital world.
And it really all comes down to this. On one hand, you've got Lossy. It gives you those super small, convenient files for your photos, your music, your videos, but the price is that some data gets thrown away forever. And on the other hand, you have Lossless. It makes a perfect bit-for-bit copy of the original. It's absolutely essential for things like software or text documents where even one tiny error could be a disaster.
And all this leaves us with a pretty fascinating final thought, right? When you get down to it, lossy compression is really the science of letting things go. We're creating more data now than ever before in human history. So maybe the biggest challenge ahead isn't just about finding more space to store it all, but about getting better at deciding what's truly important enough to keep in the first place.